Imagine two identical triangles sitting on a coordinate plane, but one is in a different position. How did it get there? Was it picked up and moved? Or did it slide smoothly into place? This is what we call a translation. And today, we're going to learn how to determine exactly how far and in what direction a shape has moved. A translation moves every point of a shape the same distance in the same direction. But how do we figure out how much it moved? Simple. We compare the original shape with the translated one by tracking the movement of each point. Let's take a triangle with one point at 2, 3. Now, look at where that same point is in the translated triangle. Let's say it moved to -3, 6. To figure out the translation, we compare the x-coordinates first. The original x-coordinate was 2, and the new x-coordinate is -3. That means the point moved 5 spaces to the left. Now, let's check the y-coordinates. The original y was 3, and the new y is 6. That means the point moved 3 spaces up. Since every point in the triangle follows the same movement, 5 spaces left and 3 spaces up, we can describe the translation as move 5 left and 3 up. Let's try another one. Suppose a different triangle has a point at -4, 1. After the translation, that point is now at -1, -1. We start by checking the x-coordinates. The original x was -4, and the new x is -1. That means the point moved 3 spaces to the right. Now, we check the y-coordinates. The original y was 1, and the new y is -1. That means the point moved 2 spaces down. Since all points in the triangle follow this same shift, 3 spaces right and 2 spaces down, we can describe this translation as move 3 right and 2 down. Think about it like this. If you slide a book across a table, every part of the book moves together. It doesn't rotate, flip, or change size. It just shifts. That's exactly how translations work in math. Now that you know how to determine translations, let's put this into action. Get ready to analyze translations on the coordinate plane and see just how simple it is to track movement in geometry. Let's dive in.